So it should be recording. Got it. I don't even know why they give that that warning there. Okay. So let's take a look at the questions here. And let's give it a second. All right, so you start on number 10. Okay, perfect. So let's work on it. Let me go ahead and minimize this here on my side. All right, it says there, the volume of a cylinder is given by the formula V equals pi r squared times the height. Find the greatest and least values of V. So they want you to find the max of V and the min of V. And they say, they give you a restriction. The restriction is that the radius plus the height must equal to 6. And then they want the formula for volume of a cylinder. The formula for the volume of a cylinder is volume equals pi r squared times the height. So if we take a look at that right now, we realize that we want to find a derivative of volume, right? Of the volume. But here's the problem. We have two variables. We have r and we have height. So we have two variables. Yes. So there's the question right there. All right, no problem. Okay, so we got to get the derivative, but we got two variables here. And so I guess we can begin by saying that r equals 6 minus h. So r is 6 minus h. So therefore, I can now take this here and substitute it there. Or the one I like the most is I would like to do it this way. I like doing it h equals 6 minus r. It's so much better. So you can do that too. So I'm going to go ahead and do it that way.
Is that a 6 or
A 6. I'll make it prettier. Give me 1 second. Give me 1 second. That is my plumber calling me. Zoom recording. All right. So I would rather substitute the h in there with the r. So now you have the following. You have v equals pi r squared times 6 minus r. Right? So that's what we got. Now, you can go ahead and write this as v equals, and what I would do is I would distribute. You see that? I would distribute 6 pi r squared minus pi r to the third. And now everything's in terms of r. So now you can do your derivative, dv dr. There's another way of writing it. It's Leibniz. I'm sure I'm saying it wrong. Notation, Leibniz notation, or Leibniz. And now you go, well, that's going to be 12 pi r minus 3 pi r squared. You saw what I did there? Because the 6 and the pi are constants. The variable there is r. You see that? And so you don't have to write 3.14. Just leave it as pi. And now, when do we have a stationary point? Because we're trying to find a maximum here or a minimum. And that happens when we have a stationary point. And stationary points happen when dv dr equals to, so you got 12 pi r minus 3 pi r squared equals to 0. Right? And so now you got to decide how you're going to solve that. I mean, there's a few ways. I'm going to go ahead and I'm gonna go ahead and factor out a 3 and a pi. And so you have 4 r, not 4, I'm gonna leave the r's in for now. 4r minus r squared. Okay, that's okay. And I'm gonna divide everything by 3 pi, so now I'm left by 4r minus r squared equals 0. And then you can see that you can factor out an r now. R times 4 minus r equals 0. So you have r equals 0 and r equals to 4. And you're done.
What happened to the 3?
Well, right here, I just told myself, hey, I have 3 pi, 4r minus r squared equals 0. I'm like, I can just divide both sides by 3 pi. This makes it go bye-bye. And then I'm just left with that.
Oh.
Just a little, And now you should see what's the max and what's the min here, right? So, yeah.
How come R is 0 and R is 4?
Okay, so that's something I have to talk about right now. So we got to find out which is the max, which is the min. Now, from a physical standpoint, when R is 0, there's no cylinder.
There's no one?
There's no cylinder. So remember, this is a cylinder, right? And you have your radius here and you have your height here. Now it's telling us R is 4 and R is 0. Now we gotta see which is the max and which is the min, but you can already tell that when R is 0, when this guy here is 0, is there a cylinder? It doesn't exist. So obviously it's gonna be the minimum, but it's of course it's a minimum because the cylinder doesn't exist. Now when it's 4, it says it's the max. But let's go ahead and do the number line here. I'll just do it over here. And then we can see we answered the question. We wouldn't have answered the question yet, though. The question asked for what V is at maximum and V is at minimum. So let's go ahead and do 0 and 4. So we have here 3. And we're going to test 3. So let's go ahead and substitute 3 into, we're going to have to substitute it into the derivative, correct? So we're going to substitute it into this guy. So basically you have 12 times 3, 36 pi, minus 9 times 3, 27 pi. Obviously that comes out positive. So over here it's positive. So the function is increasing between 0 and 3. So let's test over here at 5 what happens. 12 pi. 12 times 5, that's 60 pi. 60 pi. Minus 75 pi. Obviously, it's going to come out negative. So now we know. So it's increasing, decreasing. So this is going to be a local maximum. Okay. It's probably going to be the maximum. Okay. And now at 0, we're going to test on the other side of 0. Obviously, it makes no sense to test -1. Well, because can you have -1 radius?
No.
No, but let's just do it just for fun. So -12 pi minus, and then now you have -1 squared is 1 times 3, 3, so it's minus 3 pi. So we're testing -1 here. And so it's going to be decreasing. Okay, it's going to be decreasing. So here it's decreasing, increasing. This is going to be the min, but in reality, it's not just the min. It's just like the cylinder doesn't exist. But we're not done with the question, because what they want us to ultimately do is they want us to find out what the volume is at the maximum. So if volume equals pi r squared times the height, if r equals to 4, right, then h, which equals 6 minus r, it's 6 minus 4, so h is 2. So we have pi times 4 squared times 2. And so we have pi times 16 times 2. And then you have 32 pi. and you're done. That's the volume for the max. The volume for the minimum will be 0. Make sense? That's it. Take care, man. So, were you able to do that for homework or close to it?
I got like the beginning, but then I didn't.
You couldn't. So, but where did you? So you got here to the substitution part, right? You got to here?
Yeah.
So you actually wrote this out. No, sorry, here. And then did you do this?
No.
But do you see how I did it?
Yeah.
And then you see how I solved it? And hopefully you can practice again. Look, guys, look, let's just say at the end of this year, you know, you're not good enough for the test. You're not prepared enough for the test, but you did try. It doesn't matter. You've created a background that you can continue working on in college. See what I'm saying? Remember, a lot of these kids that do well on these tests, this is not their first exposure to this. They've been exposed multiple times in the last 4 years. It's not new to them because they're nerds. Okay, so you're a nerd in training. Okay, so you're working on it. So this is like your first introduction. So you keep on working on it. You should be fine. You know.
So the minimum is 0, the maximum was 4.
Was 32. Well, yeah, the R was 4, but the maximum volume would be 32 pi. 32 pi. Okay. All right, guys. But it's not that bad. He's exaggerating the amount of water. All right, guys. Do you want to try the next one?
Yes.
Okay. So the next one's actually a nice little problem. You already did this problem in 7. Well, it would be 8 and 9. It's the same problem. But let's read it together. It says a loop of string of length 1 meter, right, is formed into a rectangle. So let's make a string here. All right, here's a string that we've looped it to form a rectangle. And how long is this string? 1 meter. So the perimeter of this rectangle is 1 meter. So we'll just write 1. Now it says into a rectangle, 1 pair of opposite sides each x centimeter. So x and x. Okay, fine. So these sides have to be equal to each other. Opposite sides on a rectangle are equal. So it says calculate the value of x, which will maximize the area enclosed by the string. Okay, so let's begin. So let me think. Let's give this other side here a letter. Let's call it y. So do you agree that if I take 2x plus 2y, it must equal to 1? And do you agree that the area is going to be equal to x times y? Now, remember, what they want from the question is they want to maximize the area. So that means we have to take the derivative of the area. But what is our problem? Once again, the same problem we always have. That we have an x and a y for our area. So what we need to do is we need to express y in terms of x. Well, very easy. We could say if 2x plus 2y equals to 1, then y equals to 1 minus 2x divided by 2. See if that makes sense.
Then y equals.
Okay, fine. Over here, 2x plus 2y equals to 1. I subtract the 2x. 2y equals to 1 minus 2x. I divide by 2. Y equals 1 minus 2x divided by 2. So therefore, we can state this has to be, which makes sense. We're going to take 1, the perimeter. We're going to subtract 2 x's, right? The two sides, 2 x's. And what's left over, we have to divide it by 2 because it's going to be distributed equally amongst each of the y's. So, if all this equals to 1, I take 1, I subtract x, and I subtract x, and what's left over, I got divided by 2 because I have to distribute it equally into the y's. Make sense? Okay, so now we actually have a substitution going on here, right? We have a equals to x times 1 minus 2x divided by 2. Now, I'm going to go ahead and write this as x minus 2x squared divided by 2. Now, we don't have the tools in this class yet to deal with that just like that. But we may write it as this, half x minus 2 over 2x squared. Do you see what I did there? And I'm going to just go ahead and write a little bit prettier though. Half x minus x squared. And can you take that derivative? Oh, yes, you can. The derivative of a dA dx is half minus 2x. And we have a maximum or a min when we have a stationary point or a inflection point. So a stationary point is dA dx equals to 0, right? So we have 0 equals half minus 2x. 2x equals to half. So x equals to half divided by 2. Therefore, that equals to 1/4. Now, we remember correctly. Think about it. Y was equal to 1 minus 2x divided by 2. So 1 minus 2 times 1/4 divided by 2. So we have 1 minus half divided by 2. So we have half divided by 2. Guess what? Y is 1/4. Y is 1/4. And so we go back to our original question at the beginning up here, and I'll go back down. This is 1/4 and this is 1/4. Guess what that is? Is that a rectangle or is it a square? It's a square. And of course, the area is maximized as a square. This is important. Super important.
But why would they ask for it? Why would they say it's a rectangle? It's a square.
We just have a word for a square. That's all. In China, for example, they don't have a word for square. They call it rectangle, all sides equal. It's just, you see what I'm saying? A square is a type of rectangle with all sides equal.
So just because they say rectangle doesn't necessarily have to be a rectangle.
Can you have we just make the distinction between a rectangle. We think of it that the sides can't be equal, but in theory, yeah, a square is a rectangle. But a rectangle is not a square. Not necessarily.
The rectangle is not a square. No, it's not.
You know, you gotta look up the definitions. It doesn't matter. It's a quadrilateral. A quadrilateral with parallel sides all equal is a square. And then the sides weren't all equal. As long as they have two opposite sides that are equal, we call it a rectangle. I mean, it would be nice. Let's search for the definition.
Not exactly what they're gonna.
Yeah, but let's take a look at it. Here it is. All right, so let's do this. and search a rectangle. Rectangle. A plane figure with 4 straight sides, okay. And 4 right sides, good. Especially one with unequal adjacent sides, in contrast to a square, so they make that distinction. 1 second, guys. Roll call should be illegal. Alright, so in this case, the dictionary is making a distinction between this rectangle and the square. Especially one with unequal adjacent sides, but especially is not. A square is a type of rectangle, okay? All sides equal. That's it. Give me 1 second. Let me see. Oh, this shouldn't come out of my video, sorry. No, that was for the business. No, don't open up, no, close. Now I gotta edit that part out. All right, close. Just. How many seconds was this into the video? I don't even know. How many seconds are we into this? Who knows? Alright. Alright, so let's continue, guys. So you wanna do another question?
Yes.
Okay, is it still open? There we go. Alright, so let's zoom in here. Alright, so that was a good question. Go ahead and do the next one. The rectangle, they seem to be difficult, right? They seem to be getting harder. Next one's harder. Alright, so one side of a rectangular sheet pen is formed by a hedge. Okay. Yeah, I'm gonna have to zoom a lot more. Actually, I'm gonna go ahead and just cut it out right here and just save this recording where it is. And then we'll do this one on the board. So I'm gonna stop the recording.